Chapter 6.3, exponential functions. Let's first talk about what an exponential function is. So an exponential function is a nonlinear function, and it is usually representing a very fast growth or a very fast decay, okay? So let's go ahead and look at some examples of that. Okay, so let's write that down. An exponential function is a nonlinear function in the form y equals ab to the x power. So on a table, I'm going to show you how you can identify if it's exponential or if it's linear, okay? So for example, letter A, if you have a table, this is X, this is Y, and the numbers, the values on the table are as follows. 0, 1, 2, 3 for X, and for the Y values we have 2, 4, 6, 8. This is how we know if it's linear or nonlinear, okay? So when you graph this table, would it be a straight line or would it be an exponential function? An exponential function on a graph usually looks like this, where it shows a very fast growth, okay? Something like that. So, and then of course, a linear function would just be a straight line, okay? So we need to be able to identify what, looking at the table, is it linear or is it an exponential function? But at least you guys can hear me, right? And you can see the screen? Yes, okay. Okay, so right here from 0 to 1, we know going up by 1. And from 1 to 2 and 2 to 3, they are all going up by 1. When you look at your y value, you want to see, is it adding the same number consistently, or are you multiplying? If you're adding, then it's going to be linear. But if it's multiplication, then it's going to be exponential, okay? So how do you get from 2 to 4? Well, you can add 2 or you could multiply 2, right? But then from 4 to 6, did you add 2 or multiply by 2? Well, we added 2. So then it's not going to be times 2. And then from 6 to 8, you are adding 2. And because it's all addition, this is linear. For letter B, let's look at this table. We have X and Y. So we have 0, 1, 2, and 3. And then the y values, we have 4, 8, 16, 32. And you should be able to tell already more or less what this is going to be. From 0 to 1, we're adding 1. From 0 to 2, we're adding 1. And from 2 to 3, we're adding 1. Now, from 4 to 8, you could add 4 or multiply by 2. From 8 to 16, are we adding 4 or multiplying by 2? Well, you can see here we're multiplying by 2, which means this one is out. And then from 16 to 32, we are multiplying by 2. Because it's multiplication, then this is an exponential function. So the difference between these two is that linear have a consistent growth. It will always be consistent, but exponential means it is a very fast growth. I always think of, I don't know if you guys have seen the movie Gremlins, but when you drop water on them, then they grow exponentially. They multiply right away. Another example of exponential functions, which I really hate that I could use this example this year compared to other years that I've taught this, but an exponential growth is the example of the number of COVID cases that we've had. Since the very beginning, it just multiplied the number of cases, and that's an exponential growth, okay? Another example of exponential growth could be like mosquitoes. You could have a small amount, and then all of a sudden, it's an exponential growth of mosquitoes showing up, okay? Okay. Let's say, for example, you get a problem that's asking you, this is actually example number 3 from the book. It says to evaluate the function y equals, so, and then it says when x equals -2, 0, and 1/2. An exponential function, and the way we know it's an exponential function right here is it is in the form of y equals a b to the x power. So I wrote in blue 2 times 9 to the -2nd power. Okay, so here, do you remember that that -2 means this goes to the bottom? So this is actually 2 over 9 to the 2nd power. And when you do 2 over 9 to the 2nd power, you end up with 2 over 81. And this is the first answer. Okay. The next one is we're going to input 0. So we have 2 times 9 to the 0 power. And remember, for these, you can use the calculator. It's okay. So anything to the 0 power becomes 1. So it's 2 times 1, which is just 2. That's right. That's okay, guys. Okay, so the next thing I want to talk to you about after you write this down is the vocabulary word asymptote. Okay, so right below it, we're going to write that definition. An asymptote an asymptote is a line that a graph approaches an asymptote is a line that a graph approaches but never intersects. So let me show you what I mean by that. Okay, so this graph right here shows you an asymptote. Whenever you have an exponential function, here in yellow, you can see that there's an exponential function, right? More or less. Okay. So whenever you have an exponential function and you see that this graph is approaching this blue dotted line, that's the asymptote. Okay, that blue dotted line, that's the asymptote. So what that means is the asymptote here is this blue dotted line, which is y equals 0. And the graph is approaching it. It will never intersect the asymptote. It will never intersect it. It looks like it does, right? It looks like the yellow touches the dotted line. But when you actually zoom in and zoom in and zoom in on the graph, it will never touch it. That's what the deal is with exponential functions, okay? So that's how it looks. Now, below it, I just want to remind you about domain and range. Remember, domain is all the x values and range is the y values. And here you'll see some of your answer choices with the x and this bar right here. And the way you say it is all values of x for which. So this little bar right here is the for which. And then you say whatever's behind it, okay? So all values of x for which. So let me show you. Like these answer choices. You see here all the values of x for which x is less than or equal to 0. Okay, so look at this question. It says, what is the domain of this exponential function? Remember, domain is all of your x values. So if you look at your x values, for sure this arrow means it's going to be all the negative x values. And then when you get to the right side of it, what's happening here on this yellow exponential graph? Do you see how it keeps going on and on and on, right? Now, do you think it's going to cover all of these x values? What do you guys think? Yeah, it actually is. Very good. It is going to cover all these x values. And because of that, then your answer here would be all real numbers. Okay? All right, questions on this one? All righty, look at the next one. What is the range of this exponential function? Okay, remember that range means y. So we're looking at the y values. Okay, you notice how this graph Has nothing to do with the negative y values. So it's not less than. It can't be less than. It's got to be greater than. And do you see how you have y equals 0 here with this pink dotted line? And then you have your graph, your exponential graph in green. That means that your range can't be all real numbers because we're not including the negatives. So it can't be this one for sure. But your y values, all the values of y for which, is it y is less than or equal to 0? Well, we just said it can't be less than, so no. Is greater than or equal to 0? Now, did the green, does it intersect with the 0, y equals 0? Do you guys remember what I said earlier? Does it intersect or not? That's when I was showing you this part. Let me show you. Right here. An asymptote is a line that a graph approaches but never intersects. Does it intersect the 0? No, it does not, okay? So when you look at your answer choices here for y, is it going to be equal to 0? Here. Nope. The next one says all the values of y for which y is less than 0. Okay, are the values of the green graph less than 0 on y? No, but it's actually going to be greater than 0, so this is the best choice, okay? All right, let's look at the next one right here. What is the domain of this exponential function? Okay, so what I would do here is graph it on your graphing calculator and see what the domain is. When you graph this, you're going to end up with a graph that looks like this. So what do you think is the domain? Remember, domain is all your x values. What would be the best answer here? Yes, that's it. Very good. Okay, let's look at the last one here. What is the range of this exponential function? Okay, plug this in to see how it looks into your graph. All right, guys, so what's the range here? We're talking about range, not domain. That's it. Yep. Very good. It has to be greater than 0. Yep. So we're going to choose this one, okay? It has to be greater than 0. Okay, not the equal to, not all real numbers, and so forth. Okay, guys. I'm going to have you work on today's assignment, which is going to be iExcel, Algebra, X3.